Okay, we're going to see if we can finish up section 1.6 very quickly. So always start by isolating the radical whenever you have a radical equation where you want to solve. First thing you do is get the radical by itself. So we're going to add 4 to both sides of this equation. Square root of x plus 10 equals x plus 4. And then we are going to square both sides of the equation. So when you do that, the left side will just become x plus 10, and the right side will be the quantity x plus 4, quantity squared. And when you square a binomial, you are going to get x squared plus 8x plus 16. And now we can see that we have a quadratic, so we want to get everything on one side, set it all equal to 0. So x squared plus 7x plus 6 equals 0. And we can see that that is factorable. X plus 6 times x plus 1 equals 0. And if you multiply two things together to get 0, it means one of them has to be 0. So either x equals -6, which would make the first factor 0, or x equals -1, which would make the second factor 0. So the two choices, the two solutions we get are x equals -6 and x equals -1. But we have to remember that we may have added solutions that don't actually work in the original equation. So we need to check both answers to make sure they actually work in the original equation before we did anything to it. So we will check -6, put it in there. We've got the square root of -6 plus 10 minus 4 is supposed to equal -6. Square root of 4 minus 4 is not going to equal -6 because that's 2 minus 4. So 2 minus 4 does not equal -6. And so therefore that is not a solution. -6 is not a solution. If we try -1, we will have the square root of -1 plus 10 minus 4 equals -1, which is the square root of 9 minus 4 is supposed to be -1. 3 minus 4 actually is -1. So yes, that does work. So -1 is the solution. And that would be our solution set. So always, 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 whenever you square both sides of an equation or cube both sides or anything like that, you might be adding solutions that don't actually work. Make sure you check all your solutions in the original equation. All right, this one has 2 radicals, so what you're going to have to do now is you're going to have to isolate them one at a time. To do that, we are going to leave the square root of m minus 1 on the left, and we're going to move the square root of 3m plus 1 to the right. We're adding that on both sides. Now we have to square both sides of this equation. And so the left side is simple. You just write m minus 1. On the right side, you have to square that thing, which means that you are squaring a binomial, basically. So you've got the first thing squared minus 2 times the first thing times the second thing plus the second thing squared. And what I mean by that is that you should know, let me grab a pen here. You should know that a plus b quantity squared is equal to a squared plus 2ab plus b squared. So just like we were talking today about the sum and difference of cubes, the difference of squares, you should know by heart how to square a binomial without having to FOIL the whole thing out. It is, if you got a first thing and a second thing, when you square that binomial, it's first thing squared plus 2 times first thing times second thing plus second thing squared. All right, so we squared that right side, and now we just need to clean it up a little bit. M minus 1 is going to equal 3m plus 1 minus 4 times the square root of 3m plus 1, and then you still have that 4 on the end. So now you're going to isolate that radical, that square root of 3m plus 1. So you're going to move all the m's and all the constants to one side and move the radical to the other side. And this is where I guess I'm probably confusing you sometimes, because what I did here is I moved all the stuff on the left over to the right, and I moved the square root, the 4 squared of 3m plus 1, to the left side, but then I flipped the equation. So I think that's probably what was confusing about what I did today when I made that mistake and we couldn't figure it out. But I still made a mistake, but I'm just saying sometimes to get everything to be positive, I will do things that it doesn't seem to make sense at the time. So I'll show you what I am doing. So the way I do this is, so I'm moving the 4 square root of 3m plus 1 to the left side. So 4 square root of 3m plus 1. So that's positive. Moving everything else to the other side. So 2m, you're subtracting m from both sides, and you're adding 1 to both sides. So that's going to be plus 2 plus 4. That's going to be plus 6. So this is what I'm really doing, but I'm just putting that on the left and that on the right. So sometimes it can be confusing, but that's what I did. Anyway, moving on. So the first thing I'm doing here is dividing everything by 2, just because I noticed real quickly that everything had a factor of 2 in it. And then I'm going to just go ahead and square both sides. So I'm going to have m plus 3 quantity squared and 2 square root of 3m plus 1 quantity squared. I could have divided both sides by 2 first and then squared it, but that just seemed like it would be easier to do it this way. So squaring both sides, you've got m squared plus 6m plus 9, and then you've got 4 times 3m plus 1. And now you can distribute that 4 on the right side and subtract everything so that you have everything on the left side of the equation. And then you can add your like terms. So m squared minus 6m plus 5 equals 0. And that is a quadratic. And it can be factored into m minus 5, m minus 1 equals 0. So m could be 5 or m could be 1. That would make those two factors equal to 0, but we have to check to make sure that they work. So if m is 5, we'll check that. That would be the square root of 5 minus 1 minus the square root of 15 plus 1, and that's supposed to equal negative 2. So you've got the square root of 4 minus the square root of 16 is supposed to equal negative 2. So that's 2 minus 4 equals negative 2, which is true. So 5 is a solution. If you try 1 for m, you're going to have the square root of m minus 1, 1 minus 1, minus the square root of 3 times 1 plus 1, and that's supposed to equal negative 2. And so you've got 0 minus 2 is negative 2. That is true. So both solutions, in this case, both work. So that would be your solution set. Okay, so rational exponents, that's just an exponent that looks like a fraction. Remember, ratio means fraction, rational fraction. So you've got your base, which is the big number, and then you have your little number up top, which is your exponent. And when you have a fractional exponent, the numerator tells you what power of x you want, and the denominator tells you what root you want. So for this one, you would be taking the cube root of x and raising it to the second power. So the first thing you want to do is take that fractional exponent and write it as a power and a root. So this is 2 times the cube root of x plus 1 quantity squared. And that's supposed to equal 8. All right. So you want to isolate the radical by dividing both sides by 2. So you'll have the cube root of x plus 1 quantity squared equals 4. And then you will cube both sides. So raising both sides to the third power, that makes the radical go away, and then you have 4 cubed. So we've got x plus 1 quantity squared is equal to 64. And now we want to take the square root on both sides. So take the square root, and you have x plus 1 equals plus or minus the square root of 64. Remember, when you take the square root on both sides of an equation, you have to put plus or minus. And now you can isolate x. You've got x equals negative 1 plus or minus the square root of 64. And we know that the square root of 64 is 8. So you've got x equals negative 1 plus 8 or x equals negative 1 minus 8. And that means that x would be negative 9 or 7. We have to check both of those answers because we did cube both sides of the equation. And that might have added solutions that don't actually work in the original equation. So check negative 9, put it into the original equation. You'd have 2 times negative 9 plus 1 to the 2/3 equals 8. And that would be 2 times negative 8 to the 2/3 equals 8. So 2 times cube root of negative 8 is 2. And then you square that and you get 4. So 2 times 4 does equal 8. So negative 9 is a solution. And then if you check 7, you're going to put that in. You got 2 times 7 plus 1 to the 2/3 power equals 8. So 2 times 8 to the 2/3 power is 2 times 4, and that is also 8. So it works both ways, because when you take the cube root of negative 8 or the cube root of 8, and then you square it, you're going to get a positive value. So both of those solutions actually do work in the original equation, and so that would be your solution set. Okay, solving equations that have a quadratic form. All right. Sometimes you'll have an equation that looks really ugly and terrible, and it would be kind of terrible to try to solve it as it is. So this is one of those equations. You've got 2 plus 3 over x quantity squared minus 2 plus 3 over x minus 12 equals 0. Trying to solve that would be a pain, but there's an easy way to do it if you notice that it has a quadratic form. You have a thing, 2 plus 3 over x squared, and then you have that same exact thing, 2 plus 3 over x, to the first power. And then you have a constant. And that's what a quadratic looks like. It looks like ax squared plus bx plus c equals 0. That's what a quadratic equation looks like. And so we can make this equation look like a quadratic because it's in that form. We can do it by doing a little trick of substituting an easy letter for a more complicated, ugly thing. So because this is something squared minus that same thing to the first power minus a constant, and it equals 0, what I can do is I can say, all right, well, I don't want to deal with that 2 plus 3 over x, so I am going to call it u. So we'll let u equal 2 plus 3 over x. All right. And from now on, I'm just going to give that little guy a nickname and call it u. It used to be called 2 plus 3 over x. I'm just going to call it u. And I'm going to work with u for a little while until I get the thing solved. And then I'll put the ugly stuff back in. So I can rewrite this equation as u squared minus u minus 12 equals 0, which is easy to solve. I can write it that way because u is 2 plus 3 over x. So 2 plus 3 over x squared minus 2 plus 3 over x minus 12 equals 0. So I made it look very simple now. So I can solve this easy equation, u squared minus u minus 12 equals 0, by factoring. That's going to be u minus 4 times u plus 3 equals 0. And that means if two things multiplied together give you 0, one of them has to be 0. So either u minus 4 is 0, or u plus 3 is 0. So u would be 4, or u could be negative 3. Now, I don't really care about u because I didn't want to find u. I wanted to find x because this equation is in x. I want to know the solution to that equation. Well, that's still simple because I know that u is 2 plus 3 over x. So now I can just stick it back in for u. So I'll call u by its actual name, which is 2 plus 3 over x. That is 4, or u is negative 3, so 2 plus 3 over x is negative 3. So I'm just now giving u back its old name, and now I can solve for x more easily. Subtract 2 on both sides, and you've got 3 over x is equal to 2. And then you can kind of cross multiply and get 2x equals 3. So x equals 3 halves is that solution. And then over here, you've got 2 plus 3 over x equals negative 3. You can subtract 2 on both sides, and you'll have 3 over x equals negative 5. So cross multiply, and you've got negative 5x equals 3. So x is equal to negative 3/5. So those two solutions now are solutions to the ugly equation that we didn't want to solve, because all we did was just rename the ugly stuff, solve the easy equation, and then stick the ugly stuff back in. Okay, so here is another one. This one is different because this time It's not that the bases are difficult, it's that the exponents are kind of ugly. So you've got 2w to the 2/3 minus 3w to the 1/3 minus 20 equals 0. This is in the form of a quadratic. It's just that it's 2w to the 1/3 squared minus 3w to the 1/3 to the first power minus 20 equals 0. So it immediately doesn't look like a quadratic form, but it actually is, because it's 2w to the 1/3 power squared minus 3w to the 1/3 power to the first power minus 20 equals 0. So it is something kind of like x squared, and then something, that same thing, raised to the first power, and then a constant. So this can be written as a quadratic. A little tricky to notice, but what we're going to do in this one, so that we can write it as a more simple looking quadratic, this time we're going to let u equal w to the 1/3 power. Because if we do that, we can write 2u squared, so w to the 1/3 power squared, so there's our u squared, minus 3u, so 3w to the 1/3, and then minus 20 equals 0. So I let u be w to the 1/3. This represents the original equation because of what u equals. And now I can solve it, and it's easy to solve, and then I can stick that w to the 1/3 back in to my solutions for u and see what the actual solutions are. So we can solve this by factoring. So you've got 2u and u, and then you want to find two numbers that will add up to -3. So 4 and 5 multiply together give you -20. And then to get the -3, you want minus and plus. That's going to be minus 8u plus 5u is going to give you your -3u. So that works. All right, so you've got two factors multiplied together give you 0. That means one of them has to be 0. So 2u plus 5 is 0. Or u minus 4 is 0. So 2u equals -5, which means that u is equal to -5/2. And u over here is 4. So I have u. I don't really want u. I want to know what w is. But I know u is w to the 1/3. So w to the 1/3 is equal to -5/2. And w to the 1/3 is equal to 4. We don't want w to the 1/3. We want w. We want to know what the solution to this equation is, which is w. So let's get it. Cube both sides of this equation, and you're going to have w equals -5/2 cubed. And if you cube both sides of this equation, you're going to have w equals 4 cubed. So here you have w equals -125 over 8. And here you have w equals 64. So the solution set then would be -125 over 8 and 64. Okay, so here you have another one that is clearly in the form of a quadratic. You have 2x squared minus 3, and that is squared. And then here you have 2x squared minus 3, and it's to the first power. And then you have a constant, 35. So this is in the form of a quadratic, and therefore we can write it as a quadratic if we substitute some letter for that 2x squared minus 3. So if we let u equal 2x squared minus 3, we can now write our equation in terms of u. So u squared, 2x squared minus 3, squared, plus 36u, 36 times 2x squared minus 3, plus 35 equals 0. And now that is easy to solve. It can be factored. It'll be u plus 35 times u plus 1. And so, since you have two factors multiplied together to give you 0, one of them has to be 0. So u plus 35 might be 0. U plus 1 could be 0. So u would be negative 35 and u could be negative 1. These are our two solutions. So I have the solutions for u, but I don't really want to know what u is. I want to know what x is. So I'm going to put that value back in for u. U is 2x squared minus 3. And that equals negative 35. So if I add 3 to both sides, I've got 2x squared equals negative 32. And then I'm going to divide both sides by 2, and I'll have x squared equals negative 16. Take the square root on both sides, and x equals plus or minus the square root of negative 16. So x is 4i or negative 4i. So those are two solutions there. And then I've got u equals negative 1. So 2x squared minus 3 equals negative 1. So add 3 to both sides, and that's 2. Then x squared equals 1. So x is going to be plus or minus the square root of 1, which is 1.